So I want to kind of walk through a worksheet that we would have typically done in class. And the goal is to match each of these with what the picture would look like. And I think the easiest way for us to do that is to really come up with the piecewise functions for A through F. And that will give us more practice on writing those piecewise functions anyway. So I'm going to zoom in a little bit. It is going to get a little fuzzy because these are pictures. I apologize for that. So let's do it. Let's see what's going to happen. So if we look at A, what would that piecewise function look like? So this says in the beginning it's going to start at f of t. So we're going to have f of t, and that's going to happen until we hit A. And then once we hit A, it's going to turn this piece on. So then this piece would be f of t minus f of t. And f of t minus f of t would be 0. So that's what our piecewise function would look like there. Okay, so remember how this works. This is going to take on a value. It's either going to be 0 or it's going to be 1. So up until A, this guy takes on the value of 0. So then this piece would be f of t times 0. So then we would have f of t minus f of t times 0, which would just be f of t. So that's true as long as we are between 0 and A. But then once we hit A, this piece takes on the value of 1. So then we would have f of t minus f of t times 1. And f of t minus f of t would be 0. So just remember what this guy's going to look like. Now, let's write B. So this says f of t minus b once we hit B. So before we hit B, this is going to take on a value of 0. So f of t minus b times 0 would just be 0. So it's starting at 0. But then once we hit B, it turns this piece on. So that unit function can be replaced by 1. And then we're going to hit the function f of t minus b. Now keep in mind what this t minus b is going to do to that graph of f of t. It's going to shift it right b units. And then let's look at C. So if we look at C and we want to rewrite this in terms of a piecewise function. So kind of the same thing. Up to A, this guy's going to take on a value of 0. So f of t times 0 would just be 0. And then once we hit A, it's going to turn this guy on. So that whole circled piece is going to take on the value of 1. And 1 times f of t is just going to be f of t. So we're only looking at a piece of that graph there. So let's take a minute. Let's look at those three and see if we can match which function it would look like. So here's our f of t function. So if we look at these, that's what the original f of t looks like. A says it's going to be the function f of t up to the point A. And then once we hit A, this guy's going to flatline and it's going to go to 0. So we would have f of t, just your normal f of t. But then once we hit A, instead of continuing, it's just going to be 0 down here. So if we look at those pictures, which one does that look like? So if we compare, it's going to look like number 53. So 53 is going to be paired with A. So now let's look at B. B says it's going to be the function 0 between 0 and b, and then it's going to be the function f of t. But notice f of t is shifted to the right b units. So if we were to take f of t and we were to shift it to the right b, it would look something like that. So it's going to be 0 up to b, and then it's going to be our f of t. Which graph does that look like? If we were to compare, to me it looks like number 52. So 52 is our answer there. Now let's look at C. C says it's going to be 0 between 0 and a. And then it's going to be our f of t function from a on. So it should look something like this. So which function does that one look like? So if we were to compare, it looks like number 49. So we've used 49, 52, and 53 for A, B, and C. Now let's continue with this. Let's look at D. I'm going to zoom back in here. We're going to rewrite D, E, and F now in terms of piecewise functions. So if we were to write D as a piecewise function, so this says that up until B, that unit step's going to take on a value of 0. So then we're going to have f of t minus f of t times 0, which would just be f of t. That's going to happen up to B. But then once we hit B, this is going to flip on, and that unit step's going to take on a value of 1. So then we're going to have f of t minus f of t, which would be a 0. So we could rewrite D in terms of this piecewise function. Now let's look at E. So E is going to have 3 pieces because we have a piece that's going to turn on at A and a piece that's going to turn on at B. So we're going to have 0 up to A. We're going to have between A and B, and then after we hit B. So between 0 and A, this guy is going to take on a value of 0. This guy is going to take on a value of 0. So we're going to have f of t minus f of t, which would be 0. Now, once we hit A and we're between A and B, this first piece is going to turn on. This piece is still going to be off. So this would still be f of t times 0 here. But this first could be written as f of t times 1. So we're just going to have f of t there. And then once we are past B, now we have flipped this piece on. So that unit step's going to take on a value of 1. So then we have f of t minus f of t, and that's going to bounce right back to 0. And then let's look at F. So once again, we see we're going to have 3 pieces because we have a piece that's going to flip on at A and a piece that's going to flip on at B. So if we were to kind of draw this out, we have a piece that's going to live between 0 and A, one that's going to live between A and B, and then one that's going to exist past B. So if we were to look at this first piece, so in the beginning, this guy's going to take on a value of 0 between 0 and A. So is this one. So we're going to have f of t minus A times 0 minus f of t minus A times 0. So that guy's just going to be at 0. It's going to be on that horizontal axis. And then once we're between A and B, that first piece is going to flip on, so that unit step's going to take on a value of 1. But this guy's still going to be off. So we're going to have f of t minus a minus 0, which would just be f of t minus a. And then once we get past b, then we're going to flip this guy on. So then we're going to have f of t minus a minus f of t minus a, which is going to be a 0 there. Now, notice we have f of t minus a, so this is a shift to the right a units. So we have a horizontal shift there, really similar to where we had a horizontal shift for b. So now let's match these up with the graphs. So I'm going to zoom back out again. So let's look at the first one. The first one, D, we have rewritten that unit step into a piecewise function. I think it's easier to see this as a piecewise. So this says that it's going to be f of t up to b. So if I were to draw over this graph, that's going to exist up to b. But then once I hit b, it's going to go to 0. So which graph looks like that? And if we were to compare all those, it's going to be 54. Now let's look at the next one, E. I'm going to clear my graph. So it says that we're looking at f of t from 0 to a. It's going to be flat. Then we're going to bounce up to f of t. And then we're going to bounce back to 0. So that looks like number 50. And then if we look at F, this is going to shift this graph to the right a unit. So let's draw that first. If we were to take this graph, pick it up, and move it, it would start here. It would go down, and it would come up like that. Now, between 0 and A, it's just going to be that horizontal line. Then the graph's going to exist between A and B, so this piece of the graph will exist. But then once we hit B, it's bouncing right back to that x-axis. So the only one that looks like that would be number 51. So you can see how we can take these piecewise, these unit step functions, rewrite them in terms of piecewise functions, and then do some matching to help us get there.